between, and really this is segments, so I say D is between A and B. So the first thing I did was I came over here and I drew that line. I just put D somewhere between A and B. I didn't actually put it in the middle. I just kind of just drew a dot. And then it says AD is 3x plus 1. So I put a 3x plus 1 here. DB is 2x minus 4. I put it there. And then it says AB is x plus 17. Okay, so AB is the total. I know that if I take the first part plus the second part, I get the total. And that's what I did right here. That's the segment addition postulate. First part plus second part equals total. Then the red is just me solving this. Okay, and once I got x, then I can plug back in. I plug x into here. 3 times 5 plus 1 is 16, so I know it's 16. 2 times 5 minus 4 is 6. 5 plus 17 is 22, and then I can just check my answer. 6 plus 16 is 22. Cool, I plugged them back in. All right, now this one's like an upgraded version because now I tell you that not only is f in between, but it says f is the midpoint. Okay, so draw your picture of AB, put f in the middle, and then it says AF is 3x plus 5. That means this distance is 3x plus 5. AB is 9x minus 20. That means this distance is 9x minus 20. Well, if f is in the middle, I know I can take 2 times it, 2 times AF to equal AB, meaning 2 times the first part equals the total as long as f is in the middle. And it says it's in the middle because f is in the midpoint. So I took 2 times the first one equaling the total, and then this is just me doing the algebra to solve it, and I get an x value of 10. But once I know x is 10, I can come back up here and I can plug in 10 for x. 9 times 10 is 90. 90 minus 20 is 70. And I can figure out that AB must be 70. And I've also could have plugged in 10 over here. 3 times 10 is 30. 30 plus 5 is 35. You're like, oh yeah, this is 35 and this is 35, which makes the total 70. And it all makes sense. Next one, find the perimeter of a triangle. Remember, the perimeter of a triangle is the same thing as the distance around. So this one is just straight up. So that side length is really easy. I'm just going to go straight up, and I went from a -5 to a 6, and that's 11. So I know that that side is 11. Okay, I'm going to delete that. Now let's focus on this distance. I want to know that distance. And so what I did is I counted 10 over and 7 up, meaning I'm going from here to here. -2 to 8 is 10. -5 to 2 is 7, and then I did a Pythagorean theorem. Okay, hang on to that number. That right there is this distance. Okay, so let's get rid of that, and now I want this distance. Well, that's its own triangle up here. It's the red triangle. 10 over 4 down. So I did 10 squared plus 4 squared equals z squared, and now I know that distance. So now I have 11, this number, and I say, round your answer to the nearest tenth, which means you're allowed to use your calculator. So just type in square root of 149 plus 11 plus square root of 116, and you get that. So we rounded to the nearest tenth, we're going to get 34.0. Again, the perimeter of the triangle, what we want to do, we want to say this plus this plus this. That's the perimeter of the blue triangle. And again, basically we had to do the Pythagorean theorem twice. Once to find z and once to find x. All right, the word bisect, remember, to bisect means to cut perfectly into half. So really, when I say find the point of intersection or find the bisector, I'm just saying find the midpoint. And so I just found the middle. Again, you can add them up and divide by 2, or you literally can just say what's in the middle of 2 and 10. You're like 6. What's in the middle of 3 and 17? 10. And again, you can kind of count back and forth to see how far they are away from each. All right, if I just say find the midpoint, except with this one, I kind of tricked you because I gave you C and then I gave you D, but I say D is actually the midpoint of CE. So really what we want to do is extend it to find E. And so how far down did I walk? Well, I walked 6 and then 5. Okay, we'll just walk another 6 down and 5 over, and you end up over here. Again, I didn't give you the 2 endpoints like I did up here. Endpoint, endpoint, find middle. Here I gave you an endpoint and I gave you the middle and I said find the other endpoint. So just keep walking. This one you don't have to do because this requires a quadratic, but the setup you should be able to do. So what I'm asking you to do is you should be able to handle this part. And so what you have to do is first you're going to draw a picture. And I think there's actually two answers to this, but we won't have to worry about that. A is between M and P. Okay, A is between M and P. P is between A and R. P is between A and R. And then I give you AP, MA, and PR, and MR. So I tell you all these things, and basically I say, all right, we got this one plus this one plus this one equals the total. And that's what I'm saying here. First part plus second part plus third part equals the total, and then be able to solve. And again, I did promise you on the test I won't give you a quadratic, but I could give you the same question and just get rid of that x squared stuff. All right, vertical angles. We know vertical angles are equal, meaning congruent. So if you know this and this are vertical to each other, here and here, we'll then set them equal and solve. And if you want to actually find the measure, well then again, always just plug back in x to find the measure. Well, a linear pair, those aren't equal, those are supplements. So add them up equal to 180. And again, I promise I won't give a quadratic, but you do need to know that a linear pair are supplements. So do angle 1 plus angle 2 equals 180 and then solve. Angle addition postulate, same thing as the segment addition postulate. It just says first part plus second part equals total. And that's what this is saying here. Again, if you know one of them is 25 and the other one is 75, then the total has to just be 100. It's that easy. Complements, remember complements mean 90. And this ratio thing, you can just set them, you know, if it's a 7 to 11 ratio, just call one 7x and one 11x. And what do we know? Well, they're complements. So one of them plus the other one equals 90. And then you can just solve. And again, you can always take this x value and plug it back in for x here and here to actually find the two angles and confirm that they are that ratio. Okay, so I give you a whole bunch of stuff here, and I tell you that they're verticals, but I also tell you they're supplements. And it turns out if two angles are vertical and they're supplements, well, the only way that's true is if they're actually both 90 degrees, because we know they have to add up to 180, but they also have to be equal. So that means they both have to be 90. And the last one, an angle bisector. And again, the word bisector means cut in half. So if it's an angle bisector, that means EB is the bisector. That must mean 78's on this side and 78's on this side. But then it says BG also bisects, which means this guy is a bisector of the 78. So split 78 into two, 39 and 39. And again, it says find that angle. So that angle is 39 degrees. So it's like a double bisector. So bisectors, angles, supplements, vertical, linear pair, complement, angle addition, segment addition, what it means to be between, what it means to find a midpoint, what it means to bisect, find the distance between things, or find the perimeter of a triangle, midpoint in between, again, segment addition. But all of these things, all of these questions are guaranteed to be on the test and worth reviewing.